Okay, implementing a decision tree in scikit-learn is very straightforward. It's extremely similar to what we just did with logistic regression. As a matter of fact, only a couple of very small differences. So I'm going to do the same exact thing that we did last time. I'm going to use the Seattle weather data, 100 days of it. I'm going to populate it using the same loop, just so you can see that here's the data. Run these first few lines. And then I'm going to import, instead of a linear model, I'm going to import a tree, right? And so this is this class of trees. And then instead of calling, obviously, a logistic regression, I'm going to call a decision tree classifier. And I have this criterion here called entropy. You can remove this if you want to. This is one of the variables that you can have that drives the cost function associated with the classifier. But more on this in the documentation, which you have access to in the lesson. So let's go ahead and run this and see what it looks like. And just do the score real quick. All right. So we have an accuracy of 76%, which, as you can see, is actually a pretty big improvement over the accuracy that we had using just logistic regression on the same data set, which was closer to, it was almost 10%, 10 percentage points less. So if I run through the same confusion matrix, you can see that we're really good. We're really good up top here. Actually, let's do this nicer one so we can see. So in the actual label of no rain, we predicted with perfect accuracy when there's no rain that there will be no rain using the decision tree, which is pretty cool. And then you can see down here we did not do so hot on predicting that it was going to be rain if there is rain, right? So this is, we got it wrong 24 times of 30. This is obviously the test set, or the training set, not the test set, so maybe we wouldn't perform so well on a real data set. Whenever you see something like this that you perform perfectly in one of the categories, this usually means that you've overfit to your training set, something to keep in mind. One interesting thing about the decision tree is that once you have it trained, we can visualize it. And I've got this little snippet in here. And what this does is it exports a file called this dt.file. And I'll run this real quick so you can see what that looks like. You can see that it created this dt.file. This is actually a file that's got syntax, text syntax. You can see it's kind of messy, but it represents the tree as a graph. And so we need to take this set of information and then cut and paste it into a graph builder. So I've got one up right now in this WebViz graph. I've taken it and I've just cut and paste it here in this graph viz. You've got this link in your project, but it's called webgraphviz.com. And then here's what our decision tree actually looks like. You can see that we just have the one feature. We have 100 data points, and then it initially separates down into 46 and 54, and then so if we follow down here, I've got 55 samples here, and then that gets split into 51 here and 4 here, and then you can see that we go from true binary, false binary on the right side, and then that's true of each leaf node until we get to these terminal points down here. And the data actually gets really thin. We can set the tree condition so it doesn't go this thin, which is, when you see stuff like this where you've got values down here, or each of the nodes have these single digit values, maybe you've overfit and you don't want the tree on a single feature to grow this large. But you can see that this is pretty comprehensive. This tree went through and basically kept separating itself until it got to the best possible cost, which is why we saw such good performance on the accuracy on the training set. This tree probably would not perform very well on a set of data that it has not seen yet. But interesting observation. You can see that in the decision tree environment, it's a simple change to the line of code, and then we have a classifier that performs, it looks like, a little bit better than our raw logistic tree, or our raw logistic regression.